This lesson is on solving equations with variables on both sides. So when you look at this equation, you will notice there is a term with a variable on the right side and on the left side. So let's review our 3 steps when solving an equation. So step 1 is to simplify. So you're going to look to the left side and see if there's anything we can combine, which we can't. This has an x, this one doesn't. Or check if there's anything we can distribute. There are no parentheses. Then we're going to check the right side. We can't combine 9x with negative 6. We can't distribute anything. So step 1, we're going to skip. Okay. Step 2 is I'm going to cover up, or if you have a highlighter, highlight where the variable is. But there's a problem. There's one on this side and there's one on this side. So if you remember from our lesson yesterday and the day before, there was only one variable term allowed. So we need to get rid of one of these. It does not matter which one. The work will look a little different, but you will still get the same answer. So I typically will sometimes get rid of the smaller term, so 9x. So before I can highlight, I need to get rid of. I can only have one variable term in the problem. So I'm going to subtract 9x because 9x minus 9x is 0. So now there is no x term on the right side. And then I'm going to subtract 9x on the left. Now the reason why I wrote it underneath the 13x and not the negative 22 is because these are like terms. They go together. So 13x minus 9x, those combine to make 4x. Then I'm going to bring down the negative 22 and the negative 6. Now I can do step 2. I can cover up the variable. And if there's something next to it, I need to make it go away. So I'm going to add 22. Bring down the 4x. These are different, so we're going to subtract. Then, when this is all by itself, the very last step is to divide by itself. So I'm going to divide both sides by 4. Because 4 divided by 4 is 1x. We want to know what an x equals. Whatever we do to the left, we have to do on the right side. So 16 divided by 4 is 4. Now, if we wanted to check this problem to know if this answer is right, we're going to take the original problem and wherever there's an x, we're going to plug in the answer we got, 4. So 13 times 4 minus 22. 13 times 4 is 52, minus 22 is 30. If this is the right answer, when I plug it in here, it should also give me 30. So let's check. 9 times 4 is 36. Take away 6 is 30. It made the same value on both sides, so I know 4 must be the right answer. That replaces the variable and makes both sides equivalent. Okay, let's go ahead and try another example. Example 2 here. Okay, so step 1, we're going to simplify. So I'm going to look to the left. I can't put an 8x with a negative 3. They're not like terms. So I'm going to look on the left side. I can simplify this. Step 1, I can simplify because they're on the same side. 8x and 2x. So 6x and 2x makes 8x. Okay, then step 2 is to cover up the variable. But there's 2 of them. I can't have 2. So I need to get rid of one of them. Doesn't matter which one. So 8x minus 8x makes 0x. Uh-oh. This was 0x. This is 0x. 0x is 0. This is gone. There's nothing here and there's nothing here. So I'm going to bring down what's left. I have negative 3 equals 4. It's not x equals 4. It's not x equals negative 3. The x's canceled out. They went away. When this happens and what you're left with is false, this is not true. Negative 3 does not equal 4. So when the variables disappear and what you're left with is false, it means your answer is no solution. That means there is no number you could plug in here, and here, and here, and make this side equal to this side. There is no possible number. There's no fraction, there's no decimal, there's no number out there that will make both sides balanced and equal. So when the variables cancel out and what you bring down is not a true statement here, it means no solution. Okay, let's try another one like that. Okay, so step 1 is to simplify. So I look to the left, I can't simplify. This has an x, this one doesn't. So I'm going to look to the right side. I can distribute. So 4 times 3 is 12. 4 times 2, positive 2, is 8x. Okay, step 2, I'm going to cover up the variable. But I can't, there's more than one, so I need to get rid of one of them. So I'm going to pick this one. So I'm going to put minus 8x. But that makes that go away. And it makes this one go away. There are no x's in the problem. So we're going to bring down what's left over. This time, when you read this, it says 12 equals 12. This is true. The other one was false. This one's true. When the variables go away, x doesn't equal 12. X doesn't equal 5. There is not one answer. When you get a statement that's true, it means the answer is all real numbers. There's an infinite amount of answers. That means any, all numbers. When you take this equation, so if we were to check this, so I want to make sure you understand what all real numbers means. If I take my equation, I could pick whatever number I want. So you can go ahead, pick whatever number you want x to be. So I'm going to pick a number, and I'm going to pick 5. Pick whatever number you want. This means any number is going to work. So I'm going to take my equation, I randomly picked a number 5, and let's see if this random number that I picked works. So 8 times 5 is 40, plus 12 is 52. On the right side, I'm going to do multiplication first, then I add. Order of operations. So 2 times 5 is 10, plus 3. 3 plus 10 is 13. So we got 4 times 13 is 52. It worked. I picked a random number, plugged it in, and it worked. That's what I'm saying. I'm saying any number can be x. 1/2 would work, 25 would work, any number at all. If you plug it in here, and here will always make both sides equal. So the answer is not no solution, it's all real numbers. All numbers are going to work. Okay, let's try one more example. Example 4. So step 1 is to simplify. So I look to the left, I can't simplify, it's all by itself. I look to the right, you can't put an x with a term that doesn't have an x. So I'm going to skip step 1. Step 2, I'm going to highlight. But today, there's 2 of them. You can't have one on each side, so you need to get rid of one of them. It does not matter which one. I'm going to get rid of the 7x. So if I subtract 7x, that's gone. And then I have 3x minus 7x. 7's bigger, so negative. They're different, subtract. Bring down the negative 8. Then, now, I can cover up the variable, because there's only one in the problem now. And then when this is all alone, divide by itself. So I'm going to divide by -4, so that makes a whole. A negative divided by a negative is a positive. 4 goes into 8 twice. So x equals 2. Now I just want to show you, for one example, if I take this problem, I'm going to redo it. And I want to show you that if I didn't start with -7x, if I started with 3x, the 3x side over here, I'm still going to get 2. So if instead of -7x, I do -3x, that's going to be 3x minus 3x, that's 0. And then I have 4x here. And I'm going to highlight, that's step 2. And then we're going to add 8. And then once this is all by itself, divide. So we get the same answer even if so it doesn't matter which variable you start with, you can only have one. So let's recap here. When we solve equations, we can get an answer. One answer, x equals one number. X equals one number. Or today we learned that you can have no number for x, no solution. Or we could have that x could be many numbers, all real numbers, an infinite amount of numbers for x.